All right, this is chapter 3. It'll most likely be in multiple pieces. It's very important. Out of this entire book, to get a general understanding of Java, chapter 3 and chapter 5 are the two chapters that are utmost importance. Okay? All right, chapter 3, we're going to talk about first Java program. We're going to talk about comments. We're going to talk about a main method, how braces work, system out print line. Someone actually emailed me a question on that this weekend over that. So now we're going to talk about templates and assignment statements, initialization statements. We're going to cover all kinds of stuff. Data types, what can they hold? We're going to talk about all the different ones. Arithmetic operators, increment, decrement, compound operators. You'll see those somewhere too. Typecasting, the character. It's just, I mean, this chapter goes on and on and on. It's an excellent chapter. It just has a lot of stuff in it. It's like a really good foundation. We're going to talk about the string basics and string methods. We're going to talk about just a couple of them. But you'll be using them from now on through the whole entire class. So make sure you understand those. Talk about the scanner class and so on and so forth. All right. Here's our first Java program. I'm assuming most of you have written your Hello World by now. Anyone have any problems with it? Okay.
Except for my computer shows up, doesn't show up the .java.
Yeah, but you can't compile it with robert.java.java. It won't go. I showed you how to show those extensions, didn't I? Yeah, I did.
Yeah, but I looked back on it.
Oh, okay. All right. Here's the Java program. Nicely written out. Okay. It's got a little prologue at the top we're going to talk about. The whole point of a prologue is we know who did it. Okay. Yeah, you might write this program today, but in the real world, do you really think you can be one maintaining the program from now on? No, there's no way. No programmer stays there for too long, especially with some of these programs that last for years. Okay. And then we got, some dividing. We're going to talk about how that should be. Then, basically, okay. Actually, I think it goes into this, doesn't it? Yeah. Okay. Let's talk about each one. Okay. The comments at the top says include comments in your program in order to make it more readable and understandable. First of all, I don't know who you are. Okay. Put your name in there. Okay. Sometimes you submit programs without your name in the title, and it's nice if I can bring it up and see whose it is, so that's always a good thing. Okay, got two different ways to do comments. Block comment, with a slash asterisk. Actually, I'm going to do a whole bunch of examples today, if that's okay with you guys. Okay, I'm going to bring up my Kin Dewey program here. Okay. All right, I'm going to add some comments to my code. Two different ways to add comments. First of all, is I can do a block comment. See what happened to my text the moment I did that? This means start of comment. And it thinks my whole entire program is a comment. And it's going to keep going until I put an ending comment. So if you accidentally put the beginning one in and forget the ending or the ending one, guess what happens? Whoops, darn if I hit the right button here. Your whole program will comment out if you don't do that. Okay, so that's one way. It can cover multiple lines. It can actually cover, I don't recommend doing this, but I have in the past. I could actually go in here and say, let's say, okay, I want to say void, okay? I could do that. I could actually comment in the middle of code. Totally acceptable. When I wrote my Java compiler at University of Tulsa, I had a lot of specific codes in there, and I had to remember what they were. So, yeah, I put some of them in there like that. So you could put comments in there in the middle of it. So it's a block comment, starts there, ends there. Okay? I don't recommend putting them inside your lines, though. Okay. What do you think the compiler does when I compile this? Totally removes and ignores all of them. Okay? All right, another type of comment is an inline comment or a line comment like this. That one line is now commented out. Okay? Now if I was to do that in the middle here, the end of the line is now missing. Okay? A lot of times when we're working with student stuff, I will comment out lines or comment out portions of lines or change it out. But so there's two different types. Block comments or line comments. Are we okay with that? All right. All right, context is ignored. Style requirements include a prologue section at the top of every program. Consists of a line of asterisks, a file name, the programmer's name, blank line, description lines, and then blank line, just like that. Again, I have had students who take programs from other students and turn them in as their own, and don't change this. So that's always a dead giveaway that it's somebody else's code. So, all right. So and now the description. Is that a decent description for this program? Yeah, prints a hello message. That's perfect. Don't tell me this is the driver program. I mean, no. What does the program do? Short synopsis of what the program does. Okay? All right. Okay, there. All right. Now, it says all Java programs must be enclosed in a class. Think of a class as the name of your program, which it is. Over here, the name of our program is hello.java. The class name is hello. They must match letter for letter, except for the .java. So we have the hello here, matches this hello here. We just skip the .java. Okay? If you change this to hello Ken, you would put hello Ken down here. No spaces or nothing. Okay? All right. So the name of the file must match the name of the Java class except for the .java extension added to it. It says proper style dictates the class name start with an uppercase first letter. So hello starts with a capital letter like that. Will it work otherwise? Sure it will. It's just one of those deals, why do we indent a paragraph? Just style, okay? So since Java's case sensitive means the file name should also start with an uppercase letter. They must match letter for letter. Okay, case sensitive means it does distinguish between them. If you use a language like Visual Basic, it could care less. Anyone ever write in Visual Basic? You have it in mind? Yeah, it could care less about case. And it freaks me out. All right. There's James. I was wondering what happened to you. All right. So, memorize and always use public class prior to your class name. Hence my example here. Public class Dewey Ken Hello. My file name is Dewey Ken Hello. And I notice how every first letter of every subsequent word is also capital letters. That's normally a good way of doing it. Okay? I'm just going to take my comments out just so we can get it all on the screen there. All right. So inside your class must include one or more methods. A method is a group of instructions, so on and so forth. The main method is what we use. Okay? The main method is what it looks for. Okay? And if we look at our method here, this is our main method heading. When we run our program, I can say, let's make sure my program still runs. Okay. Was this the one the never-ending loop? Yeah, that was probably not a good idea. All right. All right, I'm going to go in here, and I'm going to remove this loop, just so we have a real basic program, okay? This is pretty much Hello World. Works fine. Now, I'm going to change the name of this to main2. Okay? Compile it perfectly. So what the heck? I thought we said we need a main method. Let's run it. Whoa, main method not found. What happened was the compiler said, hey, everything looks okay. I didn't break any rules, which I didn't. Main2 is an acceptable name. But when I go to run it, it looks for a main method. Now, that is not always true with Java. For what we're doing, it is true. Okay? So it's saying, hey, it says, please define the main method as public static void main string bracket args. Even tells me exactly what it should be. So I'm like, I got to remove the 2. Then I can compile it again and then run it perfectly. Okay, everybody okay on that? You must know this. You must know this exact statement. The reason I don't like Eclipse is some of you use Eclipse. Doesn't it automatically put that in there for you? Who uses Eclipse?
It automatically puts that on there. For Eclipse, it automatically puts that up there exactly like that.
Yeah, and that's okay. But if I give it to you on a test and tell you to write that, you're going to have a real big problem. I have had people who could not write that line on a test. I'm like, come on. You had to write it with every program. So obviously you should have at least written it once. Okay? Public static void main string square brackets args. And we're going to talk about those. All right. So memorize and always use the main method heading as below. Okay? So when the program starts, it looks for main, which we already talked about. You need that. Okay. Braces. I was at a class up in Missouri recently, and a lady called them Hitchcocks. Like Alfred Hitchcock. Does kind of look like him, doesn't it?
Yeah.
So it was like an Alfred Hitchcock. So it says use braces to group things together. All right. What we mean by that is, see my main method? It's got these Hitchcocks or these braces around it. Okay. I got a method. I must have a start and an ending. My class, a start and an ending. Okay. Let's leave one off.
Remember, go, like, especially when you get into if files, which, like,
Yeah.
get them the right way.
All right. I took one out. I commented out. Let's try compiling it. Whoa, I got an error. Let's look at the error. Said blah, blah, blah. Line 8, error. Reached end of file while parsing. Well, first of all, where's line 8? So I clicked on this one. I went to line 8. It tells me this is an error. This is the error. Why is it telling me that's the error? Why am I reaching end of file while parsing?
You just need one more.
It's skipping the column.
Right. It skipped that one. So it got to this one. It says, okay, that one's the end of the main method. Then it says, where's the ending of this guy? Because what I did is, since I took this one out, it said, oh, well, that one must belong to this one then. Okay? So if you ever get a reached end of file while parsing, you're missing a bracket somewhere. Or a brace. I keep saying bracket. You're missing a brace. Okay? All right. Proper style dictates. Place an opening brace on a line by itself in the same column as the first character of the previous line. All right. Here's where Eclipse is very different. Here's what Eclipse does. That's the way Eclipse does it. A lot of programmers do it. Is that wrong? Well, let's try it. Does it still compile? Works like a champ. Again, we're just not going with that style in this class. When you get out in the real world and start doing this for a living, you do it any way you want. But for this class, that's wrong. So the brace must be on a line all by its lonesome, lined up with that P. This brace must be lined up with that P. See that? I don't want this indented in or all the way back here or anything. It must be lined up with the P. Okay. All right, so an opening brace, a line by itself. Okay. Place a closing brace on a line by itself in the same column as the opening brace. This closing brace is in the same column as this opening. This one's in the same column as this opening. Okay? Must be in the same column. Why is that important? Well, I was actually grading a program yesterday, and this guy had a bunch of different braces in it for different things throughout his program. It wasn't for your class. And they weren't lined up, and it was so hard for me to tell which one was which. I mean, some stuff was left justified, then some indented. I'm like, I couldn't follow it. When your program gets more complicated, it's so much easier to read this way. Okay? All right, got that. All right, system out print line generates the output. Okay, says put the printed item inside the parentheses. Okay, so this one in quotes. Okay, put a semicolon. So what is ln? What do you think? Line. New line, actually. All right, let's look at that. So I have system out print line. See that word, how it's a different color? It's actually like a dark blue. It's a reserved word. Okay. So this is basically the system class. And I want to get to the output component of that, and then the print line method. Okay. Okay. Now, so the print line method, I could have done just print. Let's change it. Now I'm doing it with just print. Worked perfectly. So what's the difference?
It didn't split it up.
It didn't have a carriage return or a new line at the end. I put ln. It printed hello world and did a carriage return. Could I have done it a different way? Yeah, I could have actually done this, which we're going to cover later on. I would have done the same thing. Because this basically says, hey, give me a new line. The same thing as ln does over here.
Within the quotations like that?
Yeah.
Oh, so
Yeah, it's an escape character. The compiler saw the backslash, I couldn't think of the name of that. Saw the backslash, said, whoa, there's something important coming up, and it saw the end and said, that meant carriage return. Like I could actually go in here and put a /n, and we'll put a /t. Watch this. So I got hello, 2 blank lines.
Line tab.
Then I got a tab between O and R. So you can put a bunch of those there. But we'll cover more of those. All right, so ln is new line, print line. Okay. All right. Compilation and execution. Since a graded Java program can be run on a computer, submit your code to the compiler. Okay. Now, TextPad does that for us. Did we do one manually in here? I think we did, didn't we? Did we not? I don't know. Let's do one by hand. I'm going to bring up my command prompt. I'm going to go to desktop, Java, Jaza. Okay, I'm going to save this. Okay, I'm going to delete my Dewey Ken Hello class. Y'all agree it's gone now? It's just the Java file sitting there. Okay? Alright. So if I do dir, you won't see the actually delete hello.class, so you don't think I'm cheating. Alright, now I just have the Dewey Ken hello.java. So I'm type Java Dewey Ken hello. What do you think is going to happen?
Not found.
Cannot find the main class method. It's like, hey, this is the Java. Where's the class is what it's looking for. So I'm going to change this to Java C, or Java compile, tell it what to compile, and it did it. Now I'm going to do dir, and now you'll notice I have this class file again. Now if I go back and type Java again, now it works perfectly. Now I did hello world. Okay. So you can compile with the command prompt. It's just, where'd it go? That, Java C and the Java file name, including the .java. And then to run it, it's just Java without the class or anything. It'll automatically look for the class file. Okay. Alright. So, it says, say the compiler compiles the source code, and compiling it, it generates a bytecode program that can be run by the Java virtual machine. We talked a little about that last time, but it makes it into this intermediary type called bytecode. So it takes our Java file, the .java, and makes a file with the same name except .class. Then we run the .class file. You could literally just take that class file and distribute it, and it works fine. Okay. When you submit your assignments to me, I only want the .java file. Because if you gave me the .class file, I really couldn't see what you did. I could run it, which is great. But the whole point of this class is making sure you're doing things the right way, not just getting the correct output. Okay? Alright, identifiers. They are a technical term for a name in a programming language. We have class name identifier, we have method name identifier, variable name identifiers. Okay? So it's just something you name by. Okay? When you're naming something, like when you're naming a variable like this height down here, there's a couple rules for it. Okay? Must consist entirely of letters, digits, dollar signs, and or underscore characters. So you must see spaces on that list. No. How about asterisks? No. So you can have letters, digits, dollar signs. Let's go create one. Okay. Okay. Let's create a variable. Let's make an integer. We're going to learn about those soon. See if that works. Does that work? It's all letters. So we're good with that. Okay. Let's put a 2 in it. Okay. Let's put an underscore. Let's put a space. Whoa, didn't like the space. Because basically what it said was error, semicolon expected, and it's pointing to right between it. So what it wants is it wants a semicolon in there. Because it saw a space, it didn't know what the heck to do with the 2. Let's put a dollar sign. Good. And let's put an asterisk. Nope, didn't like that one either. Same deal, semicolon needed. Okay. So we're okay on naming these things? Alright. So, letters, digits, dollar signs, and or underscores. The first character must not be a digit. Okay, let's try that one. So instead of my int 2, I'm going to be to my int. Whoop, doesn't like that one. Now I got 3 errors for that. Isn't that amazing? Okay, it says error, not a statement. Then semicolon expected. Then not a statement. So one little fix, I get 3 errors. Okay? Remove the 2, fixes all 3 errors. By the way, when you fix errors, start fixing them from the top. Now, obviously, that was all one line, but sometimes, start fixing errors from the top. We'll see more of that. Okay, if the rules are broken, you won't compile. Obviously, I think we tried each case of those. All right, now here's naming convention, the style rules. If we break these, it's going to work. It's just going to be harder to understand. Okay, and you'll lose points on your homework. Like, I definitely take off points for that. Now, hello world, I really didn't care so much. As long as it worked and it was named correctly, I was good with it. But beyond that, now you're going to need comments and all that stuff. It says use the letters and digits only. No $ or underscores, with an exception we're going to talk about later. Different languages use $ all the time as string variables, but not us. Okay, not here. Okay, again, they will work, but we just don't use them right now. Okay, all letters must be formatted with should be lowercase except the first letter of the second, third, fourth words. So when I did my example here of my int, all lowercase, then the first letter of the second word. Like if I wanted to make one called my first name, first. So everything's lowercase except for the first letter of the second and subsequent words. Everybody see that? All right. And it should be descriptive. I was grading an assignment yesterday, and a guy had a variable name of J. What's J mean to you? Jackass? I don't know. It's something. Someone gave me one with A the other day. I said, what are you, defining apples here or something? But give me names that mean something. My first name would be a good one. My integer would be a good one. I tend to like my's, which you'll see me use them quite a bit. You don't have to do that. It's just something I've done for years. Because I know it's something I'm creating. It's just something I do. You don't have to do that, but it's just something I do. All right. Now, the variables can hold one or more type of data, but they can only hold one at a time. So I can make a string variable, an integer, a double, a float, a char, a long, or whatever. Okay. But one variable can hold one data type. Okay, an integer can only hold integers. A string can only hold a string. How do they know what it is? Well, based on the declaration statement, which we're going to see. Okay, here's the declaration statement. Data type, variable name, or multiple separated by commas. Here are some examples. String, first name. So first name is my variable name. Notice the lowercase except for the n on the second word. And it's a type string. Last name of type string. Student ID of type integer. Row, comma, column are both of type integer. Everybody okay with that? Style. Should be aligned. I'm not too picky on the alignment of your comments, because depending on where your comments are, sometimes I have people who line up all their comments, but they're so far over on the screen because they had some longer line, it just made it hard to read them. So they don't have to be lined up, but it makes it easier.
Question on the comments?
Yes.
Like back on that previous screen, like if you, like above string first name, if you had your comment there with 2 slashes and then whatever it was.
Yeah, if you wanted to say, I mean, for this example right here, if you said define variables would even be sufficient, because those names are explanatory enough. Okay? But yeah, if you wanted it right above it, like if I went in here to my code and said right above it, I got my caps lock on. I'm fine with that. The reason is, if I, say I want to put a comment here, and then, print line. To make the style wise, you'd have to line all these up, and the problem is they start getting way over to the right. And if you try to put comments on longer lines of code, well, then they get all further over. Then you have to move them all over. So that's the only one I don't particularly really worry about, is because it makes it harder to see them all. Then I have to go down here and scroll the program back and forth to read them, and I'd rather see them like this. If you're going to put one here, great. You put it right after it, put it above it, that's fine. Okay? All right. Any other questions on that? Everybody okay with that? All right. Assignment statements. The Java uses a single equal sign to assign variables. Okay. Here's code that says assigns the value of 50,000 to the variable salary. It's not a bad salary. So what we did here, let's talk about this. First thing we did was we declared a variable of type integer. It's going to be called salary. Now I declared a variable called bonus message. You notice the first letters of the second word is uppercase. Of type string. And I say salary equals $50,000. Okay? Don't put commas. Don't put dollar signs. Don't put any of that stuff in there. Okay? So I could have actually done these two on the same line, which we'll see about here soon. Okay? So this equal sign is not really an equal sign. It's really an assignment operator. We'll see how I use it as an equal sign later. What this reads is salary is equal to $50,000. So I'm assigning the variable, the value 50,000 to salary. So far so good? Okay? Then bonus message is equal to, now here I got some strings going on. Okay? I have bonus equals dollar. Okay? This is a string. The reason I know it's a string is inside of quotes. Okay? Bonus equals dollar. That's all my bonus equals, right? I mean, that's what that string bonus, remember, bonus message is a string. We know that because it's declared right there. So that string is bonus equals dollar. Then I'm going to add something to it. But this is not a plus sign. It is, but it isn't. It's not, I mean, it can be used to increment, like add stuff together. But in this format here, it's called string concatenation. It's adding this string to this value. So his bonus will be 0.02 times whatever his salary happens to be, which in this case is $50,000. So it's going to take the salary of $50,000, multiply it times 0.02, then it's going to add it to this string. Okay? And actually I can, let's run that one.
Actually, I was going to ask a question.
Sure.
Is it trying to print a line saying bonus equals and then the dollar sign the amount that you're going to get in the bonus? Because it wouldn't actually print that line.
No, it would not, because we haven't done anything yet. That's good. Let me put it in here. Okay, so if I go to run this, all I did was copy the code off the page and put it in here. Compiles perfectly, and I run it, I get hello world. I didn't do anything with it. I said declare variable salary, declare bonus message, do a little bit of stuff here, and then print hello world. So how could I change mine to print out the bonus message? Anybody?
Print line.
What if I take this out? What do I need to put there? Because this is the variable. And there it is. I'm giving it a value. So let's go now. Bonus is equals to $1,000. So what it did was it took bonus equals dollar. Then it multiplied this out. We know it did math because it's inside parentheses. Then it concatenated this result, which was 1,000.0. And it added it to this string. That's where the dollar sign came from. I mean, I could have put anything there. I could put an @ sign. So the dollar sign's not coming from the math. Okay?
So you're changing the variable to actually print a statement,
Yes.
essentially, with the equation.
Right. Yep. Exactly. Okay? Everybody see that? All right. So, note that the operator in the second argument statement, if the operator appears between the string and something else, then the operator performs string concatenation. That means the Java virtual machine appends the item to the right to the item on the left, forming a new string. It actually converted that number into a string, and it basically made one big old long string. Okay? All right. Tracing. All right. I'm going to try to trace here. So we have a variable called salary. Okay. What's its value on line 1? Nothing. So if I was to trace this, I would say on line 1, it's there, but it has no value yet. Okay. We have it. It's kind of like, I will be buying that house. I mean that's Ken's house, but I'm not there yet. I haven't moved in yet. Okay. And line 2, bonus message is the same thing. We know it's there. That's a question mark. I'll pretend it's a question mark. I really suck at drawing with this. I didn't bring my pen up here. All right. And line 3, what's salary?
50,000.
Okay, so on line 3 is where this finally gets a value. Oh, I really suck at this. All right. Bonus message, still a question mark. So really at line 3, bonus message is still a question mark because we don't know anything about it. Even at line 2, salary was still a question mark. Over there, we just don't have a value yet. So on line 4, what's the value of salary on line 4? It's still $50,000. We didn't change it. So pretend that's $50,000. Then bonus message becomes bonus blah, 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 blah. This whole entire thing. So on line 4, that's what becomes there. Then on line 5, that's where all this jazz right here gets output. So that happens on line 5. I'm not the best mouse drawer, by the way. All right? It says when you trace a declaration statement, write a question mark in the variable column, indicating that the variable exists, but it doesn't have a value yet. Sure, I'm glad I did that the right way. Pretty dumb if I didn't. All right. All right. Let's start with a program template. Did you ever do something, you make something, you're going to make a bunch of copies of it, so you make like a template or a pattern for something and you use it over and over and over again? That's what this is. All right. All right, it says in chapter slides, all the code fragments can be converted to complete programs by plugging them into the method body below. Okay, if you were to make a program like this, all you would have to do is go in here and change the author, change the description, change the method body, and it would work, wouldn't it? And obviously, you'd be changing the file name as well. But if you had a program template that kind of had the prologue in there, had the other stuff in there, it'll be easy, but don't rely on it too much because, again, you're going to have to learn how to write this kind of stuff. And if you don't know how to write that stuff, you're going to have an issue later. All right. Initialization statements. We already saw one. We actually saw this one right here. We saw int salary, and salary equals $50,000. Everybody see that? Okay. So we declared it on 1 and gave it a value on line 3. Whoa. Okay. Well, we could have done it all in one line. We could actually say the type, then what type is it, the variable name, and then its value. In other words, integer, total score, and then a value. So we can declare and initialize all at the same time. Okay? All right. So, that's exactly how you can do it. So we could have done over here, we could have said int salary equals $50,000 all on one line. Depends which way you want to do it. Either way is acceptable for me. Okay, here's some examples. Here's an alternative way down here. Bring my arrow back. Where'd my arrow go? I don't get an arrow anymore? There it is. All right, so down here, up here we did them both on the same line. Total score equals 0, max score is 300. Down here, int total score, int max score, total score is 0, max score is 300. Either way is fine. Whichever way you want to do it. Doesn't matter. All right, now let's talk about some data types. All right, variables can hold whole numbers. Okay, we're talking about int and long first, okay? Int and long can hold whole numbers. In other words, no decimal, no string, no nothing. It's whole numbers. Should normally be declared as integer or long, okay? They can hold negative 2 billion to positive 2 billion. That's quite a bit. Okay, so that's for an integer. Negative 2 billion to positive 2 billion. Ranges for a long are negative 9 times 10 to the 18th times 9 times 10 to the 18th. In other words, it's 9 with a whole bunch of zeros. It's quite a bit. Okay, let's actually we're going to see more about that in a minute. Okay, recommendation: use smaller types for variables that will never need to hold larger values. What do we mean by that? Okay, so if you're a single person and you always drive by yourself, never carry passengers, do you really need to buy the Cadillac Escalade with 9 seats in it? Probably not. Okay? But if you need it, then buy it. The whole point of this, if you're going to be making a variable that's going to hold the tax rate for Oklahoma, obviously it would have to be a double. But it doesn't have to be huge. Tax rates can't get that high. Now, didn't they have an issue with national debt? Wasn't a debt clock somewhere in New York? It ran out of digits or something about a year or two back. Anyone hear that on the news? The display on wherever they were outputting the national debt, it ran out of characters. So they had to modify it to handle one more because, Obama's doing a great job. Sorry. Okay.
Another zero before he leaves office.
Yes, exactly. Yeah. All right. Here are some examples. Student ID, integer. So our student IDs are 7 digits long. So would an integer be an okay data type to hold our student IDs? Even if they went to 8. I mean, we'd still fit. We'd have to have a lot of students before we ran out of digits. Okay. How about satellite distance traveled? Yeah, I mean, didn't V'ger go all the way to that planet until Star Trek found him? Star Trek 1? Y'all saw Star Trek 1? Yeah.
Long time ago.
Yeah. That was a good movie. Kind of slow, but it was alright. Okay. You never seen it? What? Alright, you need to go watch all the Star Trek movies. They're like the best. Oh, dude.
I like Star Trek.
I love Star Trek.
Was it 2 is the Wrath of Khan?
Yes,
That was the best one.
that was a good one. I like number 4, Voyage Home.
Voyage Home, I like that.
I like Voyage Home.
I have seen the new Star Trek.
Not that I have seen it 1,200 times. All right.
Like 3 times.
All right. Yeah, the new Star Trek, I like that one too. That was good. All right. So, recommendation, use smaller types when at all possible. It's like if you're going to go to the store, do you really buy the huge containers if you're only storing Ritz crackers in it? Probably not. Okay. All right. Other data types. We have float and double. Okay. Now, these can hold numbers with decimal places. Okay? So, when you hold numbers with decimal places, use float or double. Here's an example. Float GPA, double bank account balance. Obviously, they both have decimals in them. Okay? A double stores numbers using 64 bits, where a float stores numbers using 32 bits. So, which one's bigger? 64-bit. This means the double variables are better than float in terms of being able to store bigger numbers, numbers with more significant digits. All right. Now, here's where our recommendations go out the window. Remember this recommendation here at the bottom? What does it say for int and long? Use smaller types of variables that will need to hold, small data. But look over here. You should normally declare your floating point variables with a double rather than float, no matter what the size is. So if you're storing a GPA that's 1 digit at the front and 2 at the end, why would I want to store it in double that's 64 bits? Isn't that crazy? Wouldn't it make sense to use float 32? All right, we'll see why. It says in particular, don't use float variables when there are calculations involving money or scientific measurements. Those type of calculations require considerable accuracy, and float are not accurate. All right. Did anyone ever buy a Pentium 66 around Christmas time many, many moons ago? They sold them right as AMD was coming out with a line of whatever processor it was, and all the Pentiums had a floating point error in it. I bought one, and Intel sent me a brand new chip to fix my floating point problem. And the problem was like 1 in every 4 billionth time it would have a floating point error at the 400th digit or some weird stupid number like that. But it's crazy, but they can be errors. Okay, so floats can hold basically 3.4 times 10 to the 38, negative and then positive. So take 3.4, add 38 zeros, and that's how many digits it can hold. Double, on the other hand, can be 3.4 times 308 digits. So you agree the double's a little bigger? Okay, it says with doubles you can rely on 15 digits. On float you can only rely on 6. So use double. If you always use double, you'll be fine. But are we wasting memory? Yes. But, we're not making the V'ger or, Right, not anymore. But again, if I'm making a specialty something, I got to put a chip in it. Actually, my class on Wednesday night, we were talking about flash drives. I just got a 64 gig flash drive in. It's pretty big. Do y'all know what the biggest is?
256.
Actually, it's 2 terabytes.
Flash drive?
Yes. It was 256, but a company in Japan, I was watching the news on it, a student sent me an article on it. They've just made a 2 terabyte file system that will be compatible with USB 3. And it's a flash drive. It's literally a flash drive. The chip is smaller than your thumb and it'll hold 2 terabytes. So what does that mean for hard drives? It's going to be obsolete once they get them up to the speed we need. So yeah. Now 256 is the most you can buy at the moment, but the 2 terabyte one has been developed. They're waiting on the USB 3.0 standard for the whatever they did something to follow I don't know, expanded whatever file system to support it. So isn't that crazy?
That's insane.
2 terabytes on a flash drive.
That's kind of breaking to Morgan's Law like quite a bit. Like that's going well
Yeah.
beyond.
Well, you know what, it had to sooner or later. I mean, you look at a 20 gig hard drive, the olden days, and now we have, so many, they're so small. It's like, all right. I have no idea how I got there, but it's all right. Okay, assigning an integer value to a floating point works just fine. I can say bank account balance is 1,000. No problem at all. Okay? Let's do that. We haven't done an example in a few moments. Let's do salary is now going to be a double. Get rid of this stuff. Okay, we're going to give it, you don't make much, sorry. Okay. Actually, let me make it an int first. Okay. So what's it going to print out? Anybody?
1,000.
Oh, I put a period there. Whoops. Got 1,000. Everybody see that? We got 1,000. All right. Now I'm going to make it a double. Now what's it going to print out?
1,000.00.
1,000.0. Because what it did is it took this. You can always fit. It's kind of like if you got a small foot, can you put it in a big shoe?
Yep.
No problem. You just have a lot of leftover space. Okay. But what if I go the other way around? Now I'm taking something big, because is this not a double? It's got a period in it. I'll make you, 1, 2, 3. There you go. It says, whoa, can't do this. It says, error, possible loss of precision. What does that mean is our number's no longer going to be as precise as we wanted. This 1, 2, 3 is going to go away. Not that big a deal. And whenever spending time in Europe, you don't use pennies anymore. Okay? But, so sometimes it's okay, but if it was my paycheck, I kind of like to have that 0.12 whatever on the end of it. So, because it adds up. So you can always put smaller into bigger. So I can put the 1,000 into a double, but I can't put the double into an integer. Everybody see that? Very important. Okay. All right. On the other hand, assigning a float value to an integer is like putting a large object in a small box. By default, it's legal. But for this example, it ain't going to work. It'll error out. So if this is 0.0 is a very small number here. Do y'all see that? Very small number. So why can't we fit it in the count, which is an integer? I realize this is a double. I realize it's a double. Okay. But think of it. The moment we put this number here, we basically made a constant of 0.0. That's of type double. So it's 64 bits. No, it's more than 64. How big is the double? Big. 308 digits long. So it has the capability of holding that much. Even though we didn't put it in, it has the capability of it. Okay? So you can't do that. Okay? Now let's talk about constants. Constants are things that never change. Okay? The number 8, is that a constant? Sure. The number 8 was 8 yesterday. It was 8 this morning. It's still 8 now. The number 8 will never change. Okay? Negative 45 will never change. What's that? 200,000 will never change. It's something that never changes. Numbers are constants. They don't change. Floating point constant, we have, 34.6, 0.009, so on and so forth. String constants. Hello, Bob. Hi. Again, those are strings. We assign a value. They're never going to change unless we change them. Okay? But the word hello is the word hello from now until whenever. Okay? It's in the dictionary. All right. So, all right. So this is by default for an integer constant. The default is int, not long. So when I declare this 8 up here, it automatically assumes it's going to be an integer. Okay? When I define these 34.6, automatically assumes it's going to be a double. Okay? So it just takes up that much space in the computer memory. Because everything we do in this program is taking up more and more of my memory. Okay? Okay. Where are these errors? What's wrong with that first one? Anybody know?
It's a constant, it's not a.
Well, okay, but that's not really it. Let's look at this one again. The default data type for a floating point constant is double. So this 34.6 is a double. Do y'all agree with that? So here we're saying this constant of 2.30, put it in the GPA. But this 2.30, what data type is it? It's double. Double's bigger than float. It won't fit. How do I fix it? Look down here. I can say 2.30 floating point. Again, you're never going to use floating point, at least in my class, unless you're doing scientific stuff. All right. So to assign it, you do 2.30f. So we have float MPG. Okay, is this line in error? The second line error?
No, but you should only got one.
That's fine. But the next line, where we're assigning the constant to MPG, here's where we have an error. Okay? Down here, we can again fix it by declaring it a floating point. The only other way would be to make these doubles. Alright. They're split into two categories. Constants are hard-coded and named constants. It's got a few more minutes. Alright, the constants we've covered so far can be referred to as hard-coded constants. Hard-coded constants explicitly specify value. For example, numbers that don't ever change. Okay? Alright. A name constant is something that a name is associated with, like speed of light. So I could say speed of light, which is of double, is this value. Okay? Which is actually the true value. To make it a constant in Java, you put the word final in front of it, and the proper style for a constant is all uppercase and put underscores in between words. It's just so you can look at it and tell that that's a constant. Okay? Then we have propagation delay is cable length divided by speed of light, so on and so forth. Okay? Alright, named constants, we use the word final in front of it. Okay? It's where, like in Visual Basic, if you want to make a constant, it's a constant until you change it. Well, if you can change it, it's not a constant. Well, in Java, if you say something's final, you cannot give it another value. Actually, let's show that. Alright, I'm going to say final. Whoops, let's put the rest of the word there. Final salary is $1,000. Let's make sure it works. Make sure it doesn't screw up something. Alright, not a problem. Salary equals salary. I'm going to show you this. Equals plus equals 2. Anybody know what that line means? Salary is equal to salary plus 2. So results should be 1,002. We're going to cover those soon. But it's called a compound operator. If I go to compile this, I get an error. It's pointing to salary on line 7. It says error. Cannot assign a value to final variable salary. It says you can't do this because it's going to modify this, which is the final. Now if I take off the final, no problem. Now my salary is 1,002. Whole point is the final tells the system you can't change me. And it won't work. See the difference? Alright, so the final modifier tells the compiler to generate an error if the program ever tries to change it at a later time. Okay, standard coding convention says you capitalize all characters in a constant with an underscore. We talked about that. All right, there's two more benefits. They lead to code that's more understandable. If we go back to this code over here, speed of light, can you imagine if we actually had to enter 299792458.0 every time we wanted to use the speed of light in a calculation? What's the odds we actually type it right twice? Pretty slim. So if we assign it to a variable up here, like right here, speed of light, then all we have to remember is speed of light. And we can remember that. Does anyone know what pi is?
3.141526 something.
Okay. Aren't they still working on how long that, aren't they keep adding digits to it or something? Or does it go on forever? Who knows? No, they're still adding more prime numbers. That's what they're finding. But point is, it'd be a lot easier to remember speed of light than it would 299792458.0. Okay? But none of us even knew that was the speed of light. I didn't know the speed of light. Okay. Alright, so just easier to use. Alright, so using named constants could lead to code that is more understandable. What about if we were doing something for maybe a cash register program? Would it be nice if we didn't have to hard code the tax rate all throughout the program? We give it a name somewhere at the top, give it a value, something like that. So if the programmer ever needs to change the constant's value, it's easy. Find the name constant at the top, change it, then recompile and you're done. We don't have to go all throughout our code. Say the speed of light changes tomorrow. I don't know. It gets us a law, but say it changed. Everywhere we use it throughout our program, we'd have to go modify it. But if we use speed of light as the name constant, it would never change. We could just change it in one place if we needed to.
All the variables have to be declared at the beginning of the program, right?
No, they don't. They have to be declared before you use them. If I'm not using a variable to the end of my program, I can declare it at the end, just before I use it.
Can you declare everything at the beginning?
Yes, you can.
Okay.
Yes, you can. And we're going to cover, we'll talk a whole bunch more about that in the near future. All right, it's not quite time to leave, but I think it's close enough. I'm going to stop this recording. We got about 10 minutes, but it's okay. We got enough. I don't want to finish the whole chapter, or else Harold has to do homework this weekend. So. All right, so I'm going to stop this on slide 26. We're going to pick up on the next one. Discard those. Stop.